A final way to measure data is to look at the standard deviation and the variance. So this is our 1.5, variance and standard deviation. What the variance does is combines all the values in a data set to produce a measure of spread. It's the arithmetic mean of the squared difference between each value and the mean value. And so what we're going to look at here is we have this equation. So sigma squared is the variance. It is the sum of all the values, starting with the first value, multiplied by x minus mu, which is the mean, squared, divided by the number of data values. So this is our variance here, sigma squared. This is the sum of data values, starting with the first. That's what the I equals 1 means. Then we've got x, which is a data value, mu, which is our mean, and then the actual number of data values. So we're looking for a measure of how far apart each data value is from the mean. So why do we square the difference? A couple of reasons. All the terms become positive, so the values above the mean don't cancel out values below. Squaring adds more weight to larger differences. And 3, it actually makes the math relatively manageable when you're using this measure. Standard deviation is the square root of the variance, and it has the same units as the data. So standard deviation is the same formula, except instead of sigma squared, it is sigma on its own, and then we just take the square root of the right-hand side. I equals 1 to n, x minus mu, all squared, all over n, or you can remember it as the square root of the variance. Okay. A low standard deviation means that all values are very close to the mean, and a high standard deviation means that all values are spread out over the mean. Spread out over the mean. Some properties of standard deviation that it's important to be familiar with is that it's only used to measure spread or dispersion around the mean of a data set. It's never negative, and it's very sensitive to outliers. A single outlier can increase your standard deviation and then distort the representation. For data that has approximately the same mean, the greater the spread, the greater the standard deviation. If all values of a data set are the same, the standard deviation is 0 because each value is equal to the mean. So let's look at an example. Okay. So the ages of participants in a school's talent contest are as follows. Okay, we've got a collection of data here, and what we want to do is create a tally chart. Okay. We are going to do one example by hand, and then from then on, you should be putting it into your graphing calculator to find the standard deviation and the variance. Okay, you won't be asked to do it by hand on any sort of assessment. The reasoning behind this is just sort of to show you how it works, and then from then on, we'll be using technology. So let's put our ages in the different rows here, and then we're going to count the frequencies. So going through, you should have 2 participants that are 14, 3 participants that are 15, 4 participants that are 16, 6 participants that are 17, 4 that are 18, and 1 that is 19. Okay. Our f at x is just going to be our frequency times our age. So here we've got 28, 45, 64, 102, 72, 19, for a total of 330. Okay. Our next column is the x minus mu squared. So we've got x minus, well, we need to calculate what mu is, so let's do that. Our mu is 330 divided by 20, because we've got 20 here. So that's going to give us 16.5. So then when we subtract mu, we've got 14 minus 16.5 squared, which is going to give us 6.25. Next, we do 15, take away 16.5 squared, which gives us 2.25. Similarly, we would get 0.25, 0.25, 2.25, and 6.25. And then our last one is going to be f, so our frequency, multiplied by x minus mu squared. So this column multiplied by this column here. So we've got 6, oops, I'm going to go all the way back to our frequency column. Sorry about that. So frequency times x minus mu squared. So here we've got 6.25 times 2 is going to give us 12.5. Then we've got 2.25 times 3, which is 6.75. Similarly, we'd get 1, 1.5, 9, and 6.25. Now we know from our formula before we're going to have to add those up together. So we've got 37. So now we've got the sum of those values. And then we're going to calculate our variance as 37. So the sum of the difference between our data values, take away the difference of the data values and the mean. And then we're going to divide by our total number of data values. Okay. And so our standard deviation is going to end up being the square root of that value, so 37 over 20. And so we're going to get that it's equal to 1.4. So we've got our variance of our data set, and then our standard deviation here. Okay, so what that means is on average, a given data point is 1.4 approximately away from the mean. Okay. So you can see as your data set gets bigger and more complicated, it's challenging to do by hand. So you want to be familiar with doing it on your graphing calculator. So the first thing you need to do would be to enter the data. So you'd press stat, enter. Your data point is going to go in your L1 column. Your frequency is going to go in your L2 column. And then in order to get the calculations, you're going to press stat, arrow over to calculate. Then you'd press enter, L1, second, 1, okay, and then you press L2, which is second, 2, and then enter. So you should get the same result. I will add on my screen capture so you can see that. Okay. I'm going to take out that investigation here. But something else that you want to be aware of is that if you add or subtract a constant k to or from all the numbers in the list, the mean will increase or decrease by k, and the standard deviation is going to stay the same. So that's if you're adding or subtracting a constant. If you multiply or divide all the numbers in the list by a constant value k, both the mean and standard deviation are multiplied and divided by k. Now be careful here, it's the standard deviation, it's not the variance. Remember, the variance is the standard deviation squared. So dividing by k is going to have a little bit of a different impact on the variance because of the squared there, and there are a couple homework problems that give you a chance to practice that. Okay, so you can find some practice questions in 6I,